All right, guys. So we're going over the review sheet today. And we're going to finish it tomorrow. So we'll spend 2 days on this, which means your test is Wednesday. And all of your homework is due at the end of the day Wednesday. Now, problems 1 through 5 describe the transformation of each quadratic function. These here will be bonus on the test, and they're only worth 1 point apiece. We're not going to go specifically over them in class, but I will post a full video that will go over problems 1 and 2. So if you want to watch those, they will be there. So what we are going to start off with is problems 6 through 10. We're going to start off with these here. Now, with these here, we need to match up the form that they are with, and then find the vertex and axis of symmetry. Now, when we look at the first one here, this matches up to our vertex form. Our y equals a times x minus h squared plus k. And the vertex in the general form is the point h comma k. Our h value for these here is located inside the parentheses, and our k value is located outside. And for this one here, the value of k is 5, because it's plus 5 outside the parentheses, and h is 2. And it would be positive since we have minus 2 inside. It's going to come out of the parentheses as positive, giving us a vertex of 2, 5. Because our axis of symmetry for this here is x equals h. Since the h value is 2, then x equals 2. Here in a little bit. Any other questions on 6? 7 similar, but I will leave it for later. We'll look at number 8. 8 is not in vertex form. It's what we call standard form, which matches up to our ax squared plus bx plus c. Now, a, b, and c are going to be numbers. A, b, and c will not have a variable with them. A matches up with the number in front of x squared. B is the number in front of x. And c is the last one, the one without a variable. Now, for this here, we still need to find the vertex and the axis of symmetry. Now, the vertex comes in the form of negative b over 2a, comma, f of negative b over 2a. And our axis of symmetry is x is equal to negative b over 2a. So the first thing we need to find in solving these here is the value of negative b over 2a. So our b value is the number in front of x with its sign. And the number in front of x for this here is 2. And the value of a, number in front of x squared, is 1. Because our negative 1 is the value of c. Now at this point here, we could type this all into the calculator and let it do it for us. So we'd have negative 2 over 2 times 1, which is negative 1. So the x value of the vertex is negative 1. Incidentally, the axis of symmetry is x equals negative 1, because we just plugged in the value of negative b over 2a. Questions on any of this here? Now we need to find the y value of the vertex, our f of negative b over 2a. And all that's saying is taking the value of negative b over 2a and plugging it back in, replacing every x in the function with negative 1. So we have negative 1 squared plus 2 times negative 1 minus 1. Now we can calculate this out by hand, or we can plug it into the calculator. And we would type it in exactly as we see it. Parentheses, negative 1 squared plus 2 times negative 1 minus 1 is negative 2, which tells us the y value of the vertex is negative 2. So the vertex for this here is negative 1 comma negative 2. And the axis of symmetry is the equation x equals negative 1. Any questions on this here? Questions on anything we've done so far? Any other questions on 6 through 10? Any other one of these that you want to see worked? We're going to look at 11 through 15 next. And again, with 11 through 15, I would be referring back to your reference sheet, because you have a reference sheet included in the review packet. It is on the last page. And for the problems we just did and these here, I would be referring back to this here. Now for these here, they're going to come in one of two forms, either y equals or x equals. And for this here, we have y equals 1 over 4p times x minus h squared plus k. And for this here, we need to find the values of h, k, and p. Now the value of h for this one here is inside the parentheses. Well, we don't have any parentheses for this here, so the value of h is 0. K is added on to the outside. Well, we don't have anything added, a number added to the outside, so the value of k is 0. So here the value of h and k are both 0. So the only thing we need to find is the value of p. Now to get the value p, we're going to set this equation up here. 1 over 4 times whatever number is in front of the term being squared. And in this case, it's negative 1/12. And we can plug this into the calculator. We can say 1 over 4, parentheses, negative 1/12. Close parentheses, enter, is negative 3. So the value of p in this case is negative 3. Any questions on how we found h, k, or p? Now, one of the pieces that it asks for this problem is the focus. Now, if we look in the general form for y equals, the focus is the point h comma k plus p. We already know what the h value is, and since it's by itself, we can plug it in as 0. But we do need to calculate the value of k plus p. For k plus p, we know k is 0, plus the p value, which is negative 3. And 0 plus negative 3 is negative 3. The directrix for this problem here, it's y equals k minus p. Now we do need to calculate this. We can plug 0 in for k, negative 3 in for p, and 0 minus negative 3. The negative and negative make a plus, giving us 3. And the last piece of information we need for this here is the axis of symmetry. And for these here, the axis of symmetry is x equals h. Well, our h value is 0, so x equals 0. Questions on any of this here? Let's look at the next one. X equals 1/24 y squared. Now again, we'll match it up with the general form. x equals 1/4, 1 over 4p times y minus k squared plus h. And again, just like with the last one, we need the values of h, k, and p. This time the k value is inside the parentheses. But again, since we don't have a number inside the parentheses, the value of k is understood to be 0. Plus h. We don't have anything added. We don't have a number added to our squared term, so the h value is also 0. Now our p value is 1 over 4 times whatever's in front of our term being squared, which in this case is 1/24. So we have 1 over 4 times 1/24. Now we can plug this into the calculator. 1 over 4 parentheses 1 over 24. Hit enter, and we get 6. So the value p in this case is 6. Questions on how we found any of this here? Now, it didn't ask for the vertex. But if it did, the vertex for this here would be the point 0, 0, h comma k. But the focus for this one here, if we look at our general forms for x equals, it would be h plus p comma k. Now we already know what the k value is. K value is 0. But we need to see and determine what our h plus p value would be. H is 0 plus 6. H plus p would be 0 plus 6, which gives us a value of 6. So for this problem here, the focus is the point 6, 0. Our directrix is defined by the equation x equals h minus p. Well, h is 0, p is still 6, and our 0 minus 6 is -6. And then lastly, our axis of symmetry for this problem here is y equals k. In our case, the k value is 0, so we get the equation y equals 0. Questions on any of this here? Yes. Any other questions on these here? Now the next problems we're going to look at, 16 through 19, we want to find the equation from the given information. Now for all of these here on the test, you will be given the vertex in either directrix or focus. You're not going to have one where you're not given the vertex. So you're either going to have the vertex in directrix or vertex in focus. Now the directrix, if you're given it, it makes it a little bit easier to determine which equation we're using, because the directrix for our two forms, one of them is y equals k minus p, and the other is x equals h minus p. Well, because this is y equals 2, it's matching up with our y equals k minus p. It's a little bit easier to determine between the two, which is really telling us that our equation is y equals 1 over 4p times x minus h squared plus k. But it's also telling us that our focus is the point h comma k plus p. Because from the vertex to the focus, the first value didn't change, so it's still h, because our vertex is the point h comma k. But the y value of the focus from the vertex did change. We had to add something to it. Again, to solve this here, we need the values of h, k, and p. Now the vertex tells us the h value is 0 and the k value is 0, 0, 0. We'll use the directrix for this here. And what it's telling us is that when I plug in the value of k and p into this here, I will get a value, or it should simplify to 2. Well, we already know the k value is 0. So we're saying 0 minus p is 2. Well, 0 minus p is the same as just saying negative p. We do need to simplify to find out what the value of positive p is. In this case, it is negative 2. Questions on how we found h, k, or p? Now at this point here, to finish up this problem, the first thing we need to do is plug in the values of h, k, and p in. Now depending on which setup, you do need to be careful which spot h and k go into. Because with y equals, h is inside the parentheses, k is outside. With our other form, x equals, k is inside the parentheses and h is outside. Now at this point here, we do need to simplify. We can plug in our 1 over 4 times negative 2 in the calculator. And it'll tell us that it simplifies to negative 1/8. X minus 0 is the same as just x squared. And then we have our plus 0 we don't need to write in because it's understood. Questions on any of this here? Now the vertex for this here is still 0, 0. So it's still telling us the value of h and k. And again, to find this here, we'll need to find the value of h, k, and p. So from the vertex, it tells us h is 0 and k is 0. Now this time we can use the focus, because if we look at the vertex to focus, the x value, the first value, doesn't change. It's h in the vertex, which means it's still going to be h in the focus. The y value is k in the vertex, but it's now negative 7. We added something to it. So we have k plus p. Even though it went from 0 to negative 7, we did add something to it. We just added negative 7. So we get this here, which means if we look back at the general form for h comma k plus p for the focus, it's still matching up with our y equals 1 over 4p times x minus h squared plus k. And they did give us the directrix as y equals, so that still matches up to the same form. And again, on any of these here on the test, I would be referring back to that reference sheet and matching these parts up. Now for the focus, it's telling us that k plus p is equal to negative 7. Whenever we plug the k value and p value in and simplify, we should get a value of negative 7. Now at this point here, we can plug in the values we know. We know that k is 0. We don't know what p is. So we have 0 plus p equals negative 7. Now we can simplify, because 0 plus p is the same as just p, which tells us the value of p is negative 7. Our next step is to plug it back in. So we'd have y equals 1 over 4 times our value p, which is negative 7, times x minus h squared plus k. So x minus 0 squared plus 0. Now, didn't do this on the last one, but I can show you this here. So we'd have 1 over 4 times negative 7, which would be negative 128. So y equals negative 128. Our x minus 0 squared would simplify to just x squared, because if we have a number in there other than 0, so if we had x minus 1, x plus 7, we would leave it with inside the parentheses. Plus 0 doesn't add anything, so we get this here. Questions on number 17? We'll look at one more of these, and then we'll move on to the next type. Now, this one indeed did give us the vertex from the start, 0, 0. And again, vertex is our h, comma, k. And we need to find the values of h, k, and p to be able to solve this here. With it telling us that the vertex is 0, 0, it's telling us h is 0 and k is 0. Now the focus. Which one changed, the first term or the second term? So looking from vertex to focus, going from here to here. First one changed, so that means the second one is still k. Because in the vertex it says k is 0, yes? In the focus, is it still saying that k value is 0? Yeah, it's still k, which means our p value that we're adding in is being added into h. And if we look at the general form, there's one of them that does have the focus as h plus p, comma k. And that is our x equals 1 over 4p times y minus k squared plus h. We do have h, we do have k, we're just missing the value of p. And according to the focus, whenever I add the values of h and p together, we should get the value of negative 10. But we already know that h is 0. So 0 plus p is negative 10, which is telling us that p is negative 10. So we're saying h is 0, k is 0, p is negative 10. So at this point here, we could plug all this back in. So 0 and 0 for h and k. And again, make sure you're plugging them in the correct spot. You don't flip them. And then the last thing we need to do is simplify. So we can say 1 over 4 parentheses negative 10 is negative 1/40. Now our y minus 0 squared would actually just reduce to y squared. Because y minus 0 is the same as y. I square that one term, and we get y squared. Questions on this here? Questions on anything we've done so far? So I'll leave the other one there for you to work. If you do have time, it'd be good to go back and look at it. Now for 20 through 23, we want to find the vertex, focus, axis of symmetry, and the directrix. And the first thing I would do is compare these back to this form here, where h matches up to h and k. Since it started out as y equals, we'll use the y equals 1 over 4p times x minus h squared plus k. And again, just like with the previous problems, we need the values of h, k, and p. Now for us here, the k value is the outside. Since it matches up with our plus 2, outside the parentheses, it would stay the same. We're not changing the sign, so it'd still be positive 2. Our h value for this one is inside the parentheses, minus 3. The h value would indeed be 3, but it would not be negative, it would be positive. If it had been plus 3 inside the parentheses, it would have come out as negative 3. And lastly, the value of p. P is equal to 1 over 4 times whatever the amount is in front of the term being squared. So in this case, it would be 1/8. 1 over 4 parentheses 1/8 is 2. So the value P in this case is 2. Questions on how we found the values of H, K, and P. First thing we can find is the vertex, and the vertex is our point H comma K. Well, the H value in this case is 3, and the K value is 2. Again, we're just pulling from H, K, and P, these values that we found. And that gives us the vertex. Our focus in the general form for this here is H comma K plus P. And when you're doing these here, I would continuously refer back to your reference sheet so that you make sure to match these up. Our H value is still 3, but K plus P we do need to calculate. So when you say K plus P, K value is 2, P value is 2, which tells us our Y value, the focus is 4. So the focus is the 0.34. Now for the directrix, it's given to us by the equation Y equals K minus P. And for us here, K is still 2, P is still 2, and 2 minus 2 gives us 0. And lastly, axis of symmetry. The general form is X equals H. Well, our H value is 3, telling us the axis of symmetry is given to us by the equation X equals 3. Questions on any of this here? Questions on anything we've done so far? Now again, making sure to get these in the correct form is important. These are big point problems for this here. Because the vertex, the X and Y value are each worth a point. Same thing for the focus. So directrix, making sure to have it set up in the correct form as Y equals for this one here would be a point, and getting the correct value on the other side of 0 would be another point. Same thing's true for the axis of symmetry. We'll look at 21. 21 is not Y equals anymore, it is X equals. So we'll have to use the other general form for this here. And so that's telling us that X is equal to 1 over 4P times Y minus K squared plus H. So we still need to find the values of H, K, and P. Well, H in our case is now outside the parentheses. It's not inside. So the H value for this is -1. K is now inside the parentheses. And the K number would be 5, but its sign would be what? Negative. Because we have plus sign inside the parentheses, so it's going to come out as -5. And lastly is finding the value of P. So we'd have 1 over 4 times whatever number is in front of the parentheses, which would be 4. And if we plug that into the calculator, 1 over 4 times 4 would give us 1/16. Now the vertex for us here is the point H comma K. Well, our H value in this case is -1. The K value is -5. Our focus for this here, we would look at the general form for X equals, which would be H plus P comma K. So the K value is still -5, so we can just replace it. Now we do need to calculate H plus P. Well, our h value in this case is -1. Our p value is 1/16. So we do need to add -1 plus 1/16. Doing this here might be a little bit easier in the calculator. -1 plus 1/16 is -15/16. Our directrix is given to us by the equation x equals h minus p. So -1 minus 1/16. And again, we can go to the calculator. -1 minus 1/16 is -17/16. And lastly, axis of symmetry. In this case, it's y equals k, not 0, -5. Questions on any of this here? Yep. Warm air. Yeah. Well.